Okay, today I want to talk a little bit about percent composition because we've talked in the past about how compounds have these regular ratios of elements that are in them, and they are definite. And we have this law of definite proportions. We have this idea that these chemical compounds will combine together in simple whole number ratios. And we can figure out the percent composition of them if we know the mass percent of each element in the compound. So if I was to take element X, if I had the mass of that, mass percent of that, then I need to find the mass of X over the mass of the whole multiplied by 100. And so let's just look at what that would look like, because now that we know a little bit about moles, now that we know a little bit about atomic mass, then we can figure out the overall mass percent. So let's take the mass percent of something like ethanol. So eth as a prefix for organic compounds means that there are 2 carbons, and that OL ending here indicates that it's an alcohol, which means that it has this hydroxide stuck on there, or a hydroxyl group, if you're using the organic nomenclature. So we're going to calculate the mass percent, but the first thing that we need to do is to kind of think about the molar ratios of these things. So in 1 mole of my ethanol, my C2H5OH, or you could also think of it as C2H6O. Sometimes you'll see it that way as well. This really has a ratio of, 2 moles of carbon, and I have 6 moles of hydrogen, and I have 1 mole of oxygen, right? So that accounts for all of the elements in there, and these are my individual ratios. So this is important if we're doing things like stoichiometry, right? Because then I know the mole ratio of carbon to the ethanol compound as a whole. And so if I wanted to find the molar mass of this compound, then I would take 2 of my mass of carbon. So if I go to my periodic table, then the mass of my carbon is 12.01 grams per mole. So 2 times my 12.01 grams plus, if we go to my hydrogen, it's 1.008. So that would be 6 times this. And then I'm going to add to it my 1 mole of oxygen. So I'm going to the periodic table, my atomic mass, or my molar mass, the mass in grams of 1 of those moles of oxygen is going to be this many grams. And so when I add those up, and I'm thinking about significant figures here, then I'm going to have a hundredths place. That's the fewest number of hundredths places, and I'm adding them, so I know that I have to think of the fewest number of decimal places for significant figures' sake. Then I have a molar mass of my compound of 46.07 grams per 1 mole. And this is a 1, not an L. Okay, so if I want the percent composition of each, then if this is my total, this is the mass of the whole here that we're going to use, then if I wanted to find the mass percent, or the percent composition of carbon in here, then I would say, well, it's the mass of the carbon, 2 times my 12.01, divided by the whole, multiplied by 100, because it's a percentage. So this is a part out of the whole. So we'll multiply by 100, and we end up with 52.14%. Then we can do the same operation for each of my elements. So I can go from my hydrogen here. I'm going to take my 6 times my 1.008 grams, divided by the whole, multiplied by 100. Then I would get 13.13%. And now if I do the same for my oxygen, it's going to be the 16 times my 1 over the whole times 100 gives me 34.73%. Okay, now if we're looking at our answers here, and we're always paying attention to our answers to see if they make sense, then the mass of my oxygen is kind of the heaviest, and even though there's only one of them, it still accounts for quite a bit of the mass. My hydrogen, of course, is my lightest, and even though there's 6 of them, that's not going to account for very much mass. And my carbon, I have 2 of them. It's slightly less massive than my oxygen, but because there's 2, that's going to account for a larger portion of the mass. And then when I do the math and add these up, I should get 100%. And I'm good to go. That's my percent composition. Now, this all comes from these molar ratios. I had to know how many moles of each there were. I had to understand the relationship between moles and the mass on the periodic table, the atomic mass. And then I can use this information, these percent compositions, to solve different types of problems. So for example, if I was using this same information for my ethanol, I could solve a problem that looks like this. So given the work that we just did, how many grams of oxygen, and we're just talking oxygen specifically, are there in 130.7 grams of ethanol? So what I can do is use that percentage. So what we found in the last problem is the percent of my oxygen by mass is 34.73%. So that's from the problem that we got before. So I can just use this mass then, 130.7 grams. That's my whole. And then for every 100 grams of the whole that I have 34.73 grams of oxygen. So I've essentially translated my percentage into a parts out of the whole again, right? So if I was to multiply that out, I'd end up with the same thing as, multiplying by a percentage, which is just moving the decimal place, as you guys have done before in past math classes. And then when I do the math on this, I have 4 sig figs here, 4 sig figs in my percentage, so I should end up with 4 in my answer. So 45.39 grams of oxygen. Now, does this number make sense? In terms of magnitude, we would expect it to be smaller than the initial number, right? We're talking about a percentage of that initial number. We're talking about how much oxygen was in that original amount. And if we're thinking, okay, back of the envelope calculations, this is about 35%, 35% of 130. Okay, that looks like it's going to be about the 40 to 50 range. That's a good kind of guesstimate. So we know that our calculator didn't lie to us in this instance, and we can solve problems like that using that percent composition information. So just another way to use moles, another way to think about the periodic table and atomic masses, and a useful way to think about how much of each of those compounds the elements take up by mass.